In this video, we'll take a look at section 13.3, some properties of logarithms. So we found out when we defined what a logarithm was, that the logarithm is an exponent. So since a logarithm is an exponent, it has to follow all of the rules for exponents. So the first three rules that we're going to take a look at, exponent laws, and look at the corresponding logarithm law. So the exponent law, the first one, is called the product law, or the product rule. B to the power of u times b to the power of v equals b to the power of u plus v. We add the powers. So the corresponding property is, if we're taking the log base b of x plus the log base b of y, since the logarithms represent exponents, we can combine that as a single logarithm, base b of x times y. So an example of that, log base 2 of 3 plus log base 2 of 7 is equal to log base 2 of 3 times 7, which is 21. So we can combine. So we can go either direction. We can start with log base 2, 21 is the log base 2 of 3 times 7, and then split it up into log base 2, 3 plus the log base 2 of 7. Next rule is the quotient rule. When we're taking a look at exponents, the quotient rule is when you divide things with the same base, we end up subtracting the exponents. So the quotient rule for logarithms, if we take log base b of x divided by y, it equals the log base b of x minus the log base b of y. When we're dividing, we subtract the exponents. So an example is if we have the log base 3 of 1/5, we can rewrite that as the log base 3 of 1 minus the log base 3 of 5. Last rule is logarithm of a power. So in exponent laws, the power rule says if you have a b raised to a power of u raised to another power n, we multiply the powers. So log base b, x raised to the power of n, means n times log base b of x. So that power, log base b of x, raised to a power n, means multiply the powers. So if we had log base 5 of x squared, we can rewrite that as 2 times the log base 5 of x. All right, so what do we do with the properties? Well, we're going to practice a little bit taking logarithms and then expressing them as a sum, difference, or multiple by expanding them. Then we're going to take expanded and express them as a single logarithm just to get some practice with the properties. So we take a look at number 11. The three properties we're looking at are the product, quotient, and power. So number 11 is a quotient. So we're going to use the second property. So the log base 7 of 9/2 would be the log base 7 of 9 minus the log base 7 of 2. So that's it. We're just re-expressing it as a sum, difference, or multiple. Number 13, we start off with log base 2 of a to the third. That's a power to a power, so we're going to use the third property. So we multiply the power in the front, 3 times log base 2 of a. 15, we get a little bit more complicated, and it takes a couple of steps. We have log base 6 of a times b times c squared. We have 3 items multiplied together. So we're going to use the first property of logarithms, which means if you take the log of items multiplied, then we can add each together. So that's going to equal the log base 6 of a plus the log base 6 of b plus the log base 6 of c squared. Now we're not quite done yet. When we express as a sum, difference, or multiple, we have a c squared in this third term. So we have one more property that we can use. log base 6 of A plus log base 6 of B plus, now we can rewrite this as a product, 2 times log base 6 of C. So we're rewriting as a sum, difference, or multiple of individual logarithms. So we won't have any exponents or items multiplied together. Number 17, we have 10 times the log base 5 of the square root of t. The square root of t is to the power of a half. And then we have this 10 in the front, which means I can take that and multiply it up at the power. So I'm going to take log base 5. The square root of t is t to the power of a half. And I'm going to take that power and raise it to the power of 10. Okay. So we're going backwards. I should have different directions here. We're expressing it as just a single logarithm. Oops, wait, I might have just gone too much there. All right, sorry about that. Time out on that one. We're expressing as a single logarithm, so let me go back. Sorry about that. All right, we're going to go ahead and take the 10 and write it not at the top. We have t with the square root on it. So sorry about that. We have 10 log base 5. Square root of t is t to the 1/2. I don't want to write that with a power on it, so I'm going to take the power and multiply it in the front. So I get 1/2 times 10 times log base 5 of t. 1/2 times 10 is 5 log base 5 of t. Sorry about that. I was following the directions on my next set. All right, last, number 19. We want to express it as a sum, difference, or multiple. We have square root of x over a squared. So we're going to split those up using quotient rule. We get the log base 2 of the square root of x minus the log base 2 of a squared. And now I want to rewrite these so that we have single x or a single a. X is power of a half. So I'm going to take that and rewrite it as 1/2 log base 2 of x, again because x to the power of a half is the square root of x, minus, multiply the 2 in the front, 2 log base 2 of a. All right, so that's expanding, taking a single logarithm and expanding it so that you're writing it as a sum, difference, or multiple. Now we're going to go backwards, expressed as a single logarithm if we have it expressed as a sum or difference or multiple. So number 21, log base b of a plus the log base b of c, since we're adding, we can combine those into a single logarithm by taking log base b of a times c. Number 22, log base 5 of 9 minus log base 5 of 3. We're subtracting, so we can put that as a single logarithm by dividing. Log base 5 of 9 divided by 3. And in this case, we can simplify one more step. That's the log base 5 of 3, because 9 divided by 3 is 3. Next, we have log base b square root of x plus log base b x squared. We're adding. So to combine those, we're going to multiply. Square root of x is x to the 1/2 times x squared. And now what we can do is, since we're taking x to the 1/2 times x squared, we can add the powers. That's log base b of x to the power of 1/2 plus 2 is 2.5. As an improper fraction, that's x to the 5/2. Last, we have 3 expressions. So take care of the power rule first. Whenever you see items multiplied in the front, rewrite those as powers first. So we have log base e of 2 squared by taking the 2 and writing it up here, plus log base e of pi cubed minus log base e of 3. Now these are all log base e, so things that we are adding together, we're going to multiply, and subtract is the quotient. So we get log base e of 2 squared, which is 4, times pi to the third, divided by 3. And that's rewriting as a single logarithm. Okay, so practice a little bit with the properties. Then we have a few more properties. Okay, for example, we have log base b of 1 equals 0. Exponential, that means that b to the power of 0 equals 1. So that's the logarithm rule for the exponential property. Log base b of b equals 1. That means b to the power of 1 equals b. That's the exponential property expressed as a logarithm. Next, log base b of b to the x equals x. If you rewrite it as an exponent, that says b to the x is equal to b to the x. And then last, b to the power log bx is equal to x. Okay, so whenever you have b raised to the power log same base of x, the answer is going to be the power. All right, so some examples on how to determine exact value of each of the following. So number 29, we have log base 2 of 1 over 32. You can do this a couple of different ways. You can rewrite it as log base 2 of 1 minus log base 2 of 32. The log base 2 of 1, the log base 2 of 1, log base b of anything, 1, is always equal to 0, minus log base 2 of 32 means 2 to what power equals 32. So you think about that in your mind. 2 to what power equals 32. So that would be 2 to the 5th. 2 times 2 times 2 times 2, yep. So we end up with 0 minus 5, which is negative 5. So the answer to 29 is negative 5. 31, if we have log base 2 of 2 to the 2.5, this matches the property over here, log base b of b to the x is x. So since the base and this base match, log base 2 of 2 to the 2.5 is going to equal the power 2.5. Number 33, I have 6 times the log base 7, and I'm going to write that as 7 to the 1/2. Okay. So you'd be tempted to take this to the power of take 6 and multiply it. Okay, we can do that. There's a couple of different ways we can do this. Or you can recognize that we have log base 7 of 7 to the 1/2. So you can take 6 times log base 7 of 7 to the 1/2 is equal to 1/2. And we end up with 6 times 1/2, which equals 3. Last, 4 log base 4 of 8 follows this last property, the pattern. b log base b of x is x. 4 log base 4 of 8 is 8. All right, the last thing we're going to do with logarithms is use the properties to solve equations with logarithms. And what we try to do is, it's hard to solve an equation with logarithms, so we try to take and express each side as a single logarithm. We have log base b of y is equal to, I'm going to express this side as a single logarithm, log base b x squared using the power rule plus log base b of a. Now I can collect the terms on the right hand side by using the product rule. Since we have log base b x squared plus log base b of a, I can multiply x squared times a. And now notice both sides have the log base b. So you know when you have squared, you can square root both sides. In this case, we can log both sides. So if we take the log of both sides, we can unlog both sides. So if the log base b of y equals log base b of x squared a, then y has to equal x squared a. All right, let's try it one more. So the technique is to write each side as a single logarithm, and if they have the same base, then what's we're taking the log of is equal to each other. So we have log base 4 of y is equal to, we want to collect this side as a single logarithm base 4. So I have x minus log base 4 10 means we're going to divide by 10, plus log base 4 6 means we're going to multiply in the numerator by 6. So I get log base 4 of y equals log base 4 of 6x over 10. And now I can reduce my fraction. So y is equal to either 3x over 4 or 3/4 x.